The content we're trying to squeeze in, so we're going to try to keep it moving. We do have a Q&A session at the end, so feel free to jump in there and hold your questions to the end. Be glad to answer them after the talk. So actually, the talk is Oracle Interrupted, Stealing Sessions and Credentials. We're going to be looking at Oracle protocols, taking them apart. Actually, we wrote a tool called thicknet, which we're going to demo. You can jump into the middle of these sessions and actually take them over and start to put in your own queries. And we also have some stuff about downgrading protocols, things of that nature. So let's jump right in real quick. My bio, my name's Steve Ocepek. I'm the Director of Security Research at Trustwave. I have some patents. I did a lot of stuff in network access control. We've been speaking at Black Hat 2009, did Black Hat Europe 2010 a couple months ago. So I know a lot about the network layer. Wendel here, he's a security consultant, penetration tester, and he's, like me, we've both been working about 8 to 10 years in the security field. He's done a lot of conferences and published a lot of vulnerabilities along the way. Very knowledgeable. He did sort of the Oracle side, I'm more of the network side. So we're going to do a quick demo. A lot of times I like, you get into these talks and it all sounds really great, but you want to see it. I like to show the thing first and then talk about it. So we're going to do a quick demo, talk about ARP poisoning, some session injection, and then the downgrade portion of it. Real quick note about Oracle, why we picked that. Really, it's because they're the big ones. This whole thing spawned off of a pen test I was in, where I was seeing some traffic. It was Oracle traffic, and I called Wendel up and I said, "Hey, what can I do with this?" And he showed me this cool trick where he was using EtherCap to inject some traffic into already established sessions and actually changing the queries. And we said, if that works, then we could actually do that using TCP session injection. So we'll talk about what that is here in a minute. But really, the Oracle thing is really because they're big. It's not because it only works on Oracle. You could use this technology to do it on Microsoft SQL. Actually, even if you think about like Samba, Windows file sharing, things like that. Anything where you can take over a TCP session. So I'll bring up the first demo here. This one is where we're actually going to be doing the injection. So what we have, let me get back to the beginning here. So where we're kicking this off, there's this program you see. It's kind of hard to read, I'm sure, in the back. I'll just mention it's called VAMP, V-A-M-P. And what it is it's basically a utility that comes with thicknet. It's just an ARP poisoner. It has some unique ways that it does what it does, but for the purpose of discussion, it really just does ARP poisoning, which is going to get you in the middle of a conversation. It's going it's a man-in-the-middle attack, basically, on a local network. And by the way, this entire talk, you pretty much, if you're a pen tester or you're looking at the validity of this attack, keep in mind that you need to be man-in-the-middle. This whole conversation, basically, we're assuming that at this point you have a man-in-the-middle attack. So something like a layer 2 network, something like a wireless karma attack, something of that nature, or an attacker that's compromised a system on the outside and is then trying to leap into the environment. That would be a perfect example of this. So here's thicknet. Running thicknet, what happens is it drops you to a shell. Did an ls command. There's no connections going through us right now. So what's happening is this machine here, we're kind of doing a demo. We're trying to log in using SQL+, using the Wendel user. And you notice it came back and it says error, there's no such username. Well, during this, we're going to create that user. We're going to create it as the attacker. Okay? So let's try this again. This time let's pretend we're the good guys this time. We're actually going to use a real username, put a username in there, put the password in, connected to Oracle. Okay? And then just run some kind of query. So what happens is thicknet sees this in the background, and then we're going to do an ls here, and notice what happens. We see a couple of connections here. And you see source port, you see source IP, source port, destination IP, destination port. And notice at the bottom one, it's probably a squiggle for you guys, but it's like a little I. It has an exclamation mark and a little I. So what's happening here is that says that this session here is ripe for injection. So what we're going to do is do a Control-C, Control-V, paste that in there, and then take over this session. So we're dropped to another prompt here where we're actually looking at that specific session. And all we really have to do is there's a command that you can actually use to, there's a help there. So we're going to hijack it. We're going to hit I, hijack the connection, and then we've got a SQL query we're going to paste in there. Okay, so here we go. We're going to grant, it says grant connect DBA to Wendel identified by pass. Okay, so this is where we're doing the actual injection. This is really cool stuff because this screen here is the attacker, right? This screen here is the pen tester, if you will. It's whoever's. You don't really need to have any credentials. You just have to be in the way when the session is created. Actually, you can be in the way at any point during the session. And so we get some debug back. Now let's go back over, try to do what we were originally doing. We can stop our ARP poison. Basically, we can get out of the way now. We just fixed all the ARP tables, put everything back the way it was. And then we're going to do the same thing we tried to do earlier. Let's log in with our Wendel user this time and watch it work. And there we go. Okay, so this was a user creation done through an existing session. And this, as we're going to see here in a minute, this all works because there's this assumption that when you log in at the beginning of the session, that entire session is authenticated. And we're taking advantage of that.
So you took over a DBA session, is that right?
That's right. In this case, it would be a DBA session. But that brings up, that's a good question. What if it's not a DBA session? Any query, right? So if you're a user that has access to CHD, if you're a user, whatever session you take over, you've got access to whatever that user. You basically become that user for the purpose of the session. So we'll talk about, so why is that, right? So a couple things here. I threw out the ARP poisoning thing. This is old, okay? ARP poisoning's ancient. It goes back to like the 80s when switches were cool and like people, you know, the hub, we lost the hub, so you can't just open up TCP dump and stare at stuff anymore. You have to get in the way. It's a good way to find important services. It's, like I say, what we're doing with VAMP is, the only reason I wrote VAMP is because ARP spoof's a little old. We needed something to use with thicknet. It's in Perl. You can open it up, look at it. It's pretty basic stuff. But it's neat in that it's stateful, and it takes arguments. Like, notice this down here. You're saying, I want to poison everybody that is ever on the network that's between 0.100 and 0.110. So it'll keep state on that. Like I say, why this stuff still works is a lot of the people that really have been working with ARP, I mean, obviously it's one of these old protocols people don't think about very much. And it's just we're at the point now where nobody's really going to fix it. When I started down this path back in like 2000, I was doing the original network access control system. I worked at a company called WholePoint, and the arguments we got when we were looking for money is IPv6 is going to replace all this stuff. You don't have to worry about layer 2. IPv6 is coming, neighbor discovery, it's all going to be better. Well, it's 2010 now, so I mean, it's out there. Don't get me wrong, but in local networks, ARP poisoning is still extremely effective, and I think we just at least need to look at that, be aware of that. It's like we keep forgetting how bad ARP poisoning is. Other man-in-the-middle attacks, it's not just ARP poisoning. If you do a karma attack, you're in the same situation. Dynamic DNS, DHCP spoofing, remote man-in-the-middle stuff, BGP attacks type stuff. So it's not just ARP poisoning, that's just the easiest one to demo. So session injection, the reason this works, and again, I want to stress, this isn't just Oracle. Anytime you're in a situation where traffic's coming through you and you got TCP sessions, you could effectively do this attack if the protocol allows you, okay? So EtherCap can do some of this. It's not a commonly used feature. I tried originally doing this whole demo in EtherCap. I found that injection was a little difficult to get working. It does work. It's not very well documented. But EtherCap's an awesome tool. It's great to test out protocols and see how they work. But what's nice about this, again, we can keep it open as long as we want. So I come from, I'm kind of a packet head, but one of the things about TCP is it's another one of these things we kind of take for granted. So real quick crash course in TCP. Let's do it kind of like a screenplay almost, right? So quick guide to TCP. Host number 1 says, hey, let's talk, okay? That's synchronized, that's SYN, okay? Hey, I want to establish communication with you. And host number 2 says, sure, what's up, right? So that's SYN-ACK. That's synchronize and acknowledge. And the guy says, have a seat. So that's what we call the three-way handshake. That's pretty bread and butter kind of stuff. Then you have the conversation. So I went with this great girl last night. Push-ACK, that's data. Okay, so push-ACK. Oh yeah, she's someone around the office. There's some more data, and then actually it's your sister. Finn, right? Done. The conversation's over. Yeah, good talking with you. Acknowledgement that the conversation's done. That's TCP, right? That's the whole. That is ineffectively a TCP conversation. The only other layer to add to this is that you have this thing going on called sequence and acknowledgement numbers. So you've got this concept that computers being what they are, they keep track of how many bytes are in each session. So you notice I actually counted out how many characters were in this line, and so I made this little ACK47 because I got 47 bytes of data. Okay? So that's TCP. So injection, there's two types of injection really we're talking about. There's packet modification and this new thing that we're doing, which is arguably new, is not new, but it hasn't been done to this degree before that I'm aware of, which is called takeover. Okay? Packet modification is your traditional injection type case. If anybody in here does pen testing, you've got UNC injection. So you're saying, I'm looking for this pattern. And when I see this pattern, I'm going to replace it with this pattern, right? It's like a one-to-one thing. Downgrade attacks work that way. But takeover is where you're actually going to just cut the guy off that's on the other side of the communication stream, and you're going to start putting in your own stuff. This is really huge because in a lot of pen tests, and of course I'm sure attackers run into this to a certain degree, you're waiting for the client. You're waiting for the victim to do something. You're in the middle, but you feel powerless because they're sitting there and they're launching, maybe they're doing queries in the Oracle database, and they're not the queries you're looking for. There's something about inventory management you don't care. You want to get to the CHD, right? You want to get the cardholder data. So takeover is taking control. At that point, we're able to issue our own queries. We can do it asynchronously. We don't have to wait for somebody to type a certain string of bytes. But we do have to take over the whole thing, okay? So the original client's disconnected. Cut them off. There is this weird idea of multiplexing. I'm not even going to get into that, but that's something we can talk about afterwards if you're interested in it. You need to pick up on those sequence acknowledgement numbers. So remember I was talking about sequence and acknowledgement, how many bytes were sent. You have to pick up on that. You actually have to become a stack when you do this. Maintaining other artifacts, if you can do it, if you can maintain options, you can maintain TTL, that's a nice touch. The way we did this, the easy way we did this is we're using what's called a sled. Okay? So a sled is something that we can define. It's basically going to tell us what session static fields are in those packets. So basically, it's easier to illustrate it here in a minute. So there's the TCP layer. There's also this thing called TNS and Net8. In Oracle land, they have something called Transparent Network Substrate, TNS. On top of that is something called Net8. TNS, if you open it up in Wireshark, you'll see it'll say Transparent Network Substrate. You can dig down into it. It's a very simple shim. But Net8 is not well known, it's not well documented outside of people that work at Oracle. Okay, so this is a tricky one. You have to pay a lot of money to get it. There's no Wireshark decoder. There is some interesting stuff if anybody's interested here. Packet-SQL oracle.h, you Google for that. You will get some pretty cool header files. It's from somebody that worked at, I guess, ClearSight that checked that into a tree. But that was really all we had to go on, and that did help. Real quick, TNS, very simple. Packet length, checksum. Notice that's 0. They didn't bother to fill that in. That is crucial, right? Packet type is data, very simple. What is it? How long is it? Checksum. There's this reserve byte and header checksum. Notice there's a lot of fields for checksum. There's also this 4-byte bit field that is part of the spec. None of this stuff that we've seen is ever used except for packet length and the type of data that's coming next. So 3 types of messages that we've seen commonly. Net8 bundle call 035E. Okay, this is you're going to see in front of queries. This is going to be in the data stream. Piggyback calls are 11, and a lot of times you'll see these bound together with something called that's 0305. Of course, these slides are very useful. I mean, we're covering this stuff kind of quick, but these are going to be available to you afterwards as well as the thicknet source code. So don't worry if we're moving a little fast here. All this reference stuff will be available. So just a quick overview of Net8. There's a sequence number that accompanies every call. And for piggyback requests, there's a separate sequence number. So just something to be aware of, a strange artifact. Notice there's 1169. This is a piggyback call, and it's telling us what it's doing. This is the sequence number here. And notice that there's another 0035E, and then there's another sequence number over here. So it increments. There might be multiple sequence numbers per packet, basically. So the thing to take away from this part of the presentation is sled-based injection. I don't need to understand everything going on with Oracle to impersonate it. That's a common misconception. A lot of people think, I'm going to write some cool application, I'm going to get into Oracle, I'm going to get into Net 8, or whatever protocol it is, and I have to understand everything about it before I do this. That's not true. What you can use is this thing called sled-based injection, where what you're doing is you're looking for